Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my fun physics world. I really hope everybody are happy and healthy. Okay, so today we continue chapter 4, heat, 4.2 specific heat capacity. So the picture here shows two different situations. The sun heats the sand and the seawater at the same time, but the sand is hotter compared to the sea water. So what is the reason behind this? This can be explained on the concept of heat capacity. So the sand actually has lower heat capacity and the seawater has higher heat capacity. So the lower the heat capacity, the faster the object get hot. Okay, so in this case, the sand, which has lower heat capacity, will get hot quickly. And the seawater, which has high heat capacity, will get hot slowly. Okay, so these are our learning standard for today's lesson. So number one, define heat capacity. We are using symbol capital C for heat capacity. And then define specific heat capacity. So we are using small c. Okay, then number three, to state the formula of heat capacity and specific heat capacity, can see the formula here. Later I explain in more detail. And then to do experiment to determine the specific heat capacity of liquid, which is water, and then to determine the specific heat capacity of an object, a solid, which is aluminium block. And then finally, we communicate to explain the application of specific heat capacity in our daily life and in the material engineering and also in natural phenomena. Okay, so first we look at heat capacity. Okay, so heat capacity is the amount of heat required to increase the temperature of object by 1 degree Celsius or 1 Kelvin. So look at this formula. Capital C is the heat capacity, and then Q is the heat absorbed, and then delta, theta here means the changes in temperature. Okay, so C equal to Q over delta theta. And then since Q here is the heat absorbed or heat release, so the unit for heat is the same unit as the energy, which is joule. And then the temperature is in degrees Celsius, so we bring up, okay, just like in chapter 1, now you know that the unit for heat capacity is joule, okay, joule per degree Celsius. This picture shows two ball of soup, bigger ball, smaller ball. So after left to cool for some time, the soup in the larger ball is hotter compared to the soup in the smaller ball. So which one has bigger heat capacity? Yes, the larger ball soup has bigger heat capacity, hence it will cool slower. Okay, and the smaller ball has smaller heat capacity, hence it can cool faster. Okay, we repeat. Heat capacity is the amount of heat that must be supplied to the object to increase the temperature by 1 degree Celsius or 1 Kelvin. So the keyword here is only the heat, amount of heat, increase temperature by 1 degree Celsius or 1 Kelvin. Okay, the large piece of stone will have larger heat capacity than small pebble. Batu besar ada heat capacity yang lebih besar berbanding batu kecil. Okay, and then soup in the larger ball, as what we discussed just now, has larger heat capacity than soup in the smaller ball. Okay, we move on to specific heat capacity. We use small c as the symbol. Okay, so specific heat capacity is the amount of heat that must be absorbed by 1 kilogram object to increase the temperature by 1 degree Celsius or 1 Kelvin. So this is the formula for specific heat capacity. Okay, C equal to Q over M delta theta. And then try to compare this with the formula of heat capacity, capital C. Yeah? Okay, so what is the difference? Can see the difference or not? Yes, specific heat capacity must be divided by M mass. Actually, the word specific here means per mass or per kilogram. So that's why when you want to define heat capacity and the specific heat capacity, it is just like the heat capacity divided by mass. Can see or not? So this is actually heat capacity Q over changes in the temperature and then divide by M. Okay, so remember when you define specific heat capacity, you must have the word 1 kilogram. Okay, 1 kilogram. And then the unit for specific heat capacity can be derived from the formula. And see here, so this is heat energy absorbed. The unit is in joule. And then this is mass per kilogram. And then this is change in temperature per degree Celsius. So that's why the unit for specific heat capacity become joule per kilogram per degree Celsius. From the previous formula, so we get this formula of heat absorbed or heat released by the object. Q equal to mc theta or Q equal to mc delta theta. So Q is the heat absorbed or heat release, M is the mass of the object, and then C is the specific heat capacity. Delta theta means changes in temperature. If heat is absorbed, the final temperature will be more than the initial temperature. If heat is released, the initial temperature will be more than the final temperature. Okay, nevertheless, so this delta theta, the value must be positive value. Okay, all right, now, what does it mean by the specific heat capacity of aluminium as 900 joule per kg per degree Celsius? Okay, so you see now, joule is the unit for heat energy. Kilogram is the unit for mass. And then degree Celsius is the unit for temperature. So when you write your answer, the answer must have the energy, joule, and then the mass, kilogram, and then the temperature, degree Celsius. Can see here? So it means that 900 joule of heat energy is needed to supply to, you see, 1 kilogram, okay, 1 kilogram of aluminium to increase the temperature by 1 degree Celsius. And then water has the specific heat capacity of 4200 joule per kg per degree Celsius. So what does it mean? So it means that if let's say you have 1 kg water, to increase the temperature of water by 1 degree Celsius, so the water need to absorb 4200 joule of heat energy. Okay, same goes to if let's say you want to reduce the temperature by 1 degree Celsius. So for water, it need to release 4200 joule of heat energy if the mass of water is 1 kilogram. So for the aluminium, you see, aluminium, if aluminium want to decrease the temperature by 1 degree Celsius, so the aluminium, if it is the mass is 1 kilogram, it need to release 900 joule of heat energy. Okay, do you get that or not? So it means that the bigger the value of specific heat capacity, the slower for it to become cooler. Okay, and then the smaller the specific heat capacity of an object, the faster for it to become hotter or cooler. Okay, remember this formula, C equal to Q over M changes in temperature. So if let's say we have two objects that has same mass, okay, and heated, dipanaskan at an equal rate. Okay, so the object that has smaller specific heat capacity will have a faster increase in temperature. Okay, means that if let's say the specific heat capacity of the object is smaller, okay, it will become hot faster, cepat panas. Okay, heat up faster. And if let's say the same object is left to cool down, dibiarkan untuk sejuk. So the temperature of the object that has smaller specific heat capacity will drop faster. In other words, we say that the smaller the specific heat capacity, the faster the temperature drop, which means cepat sejuk. Okay, so we can summarize like this. If the object has smaller specific heat capacity, it can heat up faster and cool down faster. Cepat sejuk dan cepat panas. If let's say the object has higher specific heat capacity material, okay, it will be heat up slower and cool down slower. Okay, lambat panas, lambat sejuk. Remember that, huh? This table shows the specific heat capacity of different substance. So here you see liquid, gas, metal, and also non-metal. So for the liquid, okay, you can see water, seawater, and then ethanol, paraffin, cooking oil, and olive oil. So from here, so we know that the specific heat capacity for the olive oil is 1890. So it means that 1 kg olive oil need to absorb 1890 joule of heat energy in order to increase the temperature by 1 degree Celsius. Okay. As for metal, okay, I want to focus on this copper. So copper, the specific heat capacity for copper is 390 joule per kg per degree Celsius. So this is considered as small specific heat capacity. So it means that for 1 kg copper, in order to increase the temperature by 1 degree Celsius, so copper need to absorb 390 joule of heat energy. In this subtopic, we also do experiment to determine the specific heat capacity of liquid and solid. So as for the liquid, we'll be using water, and for the solid, we are using aluminium. So this is the apparatus setup to determine the specific heat capacity of water, and this is the apparatus setup to determine the specific heat capacity of aluminium. So the apparatus that we use are nearly the same, except that for aluminium, we use aluminium block wrapped with tissue paper. And then for water, so we add in water in a beaker, and then we wrap it by using tissue paper. Now, what is the use of wrapping beaker with tissue paper and also aluminium block with tissue paper? Okay, so we wrap both object, okay, by using insulator. It can be tissue paper, it can be towel. It's actually to reduce the energy, the heat loss to the surrounding. Okay, so in this experiment, we assume all the heat energy will be absorbed by the water. In this case, it's the water lah. And then here will be all the heat energy, okay, supplied by the immersion heater will be absorbed by aluminium block. So means that no heat energy loss to the surrounding. Okay, if let's say we want to calculate the specific heat capacity, so we must know about this. Okay, so the changes of energy. When we use the immersion heater, so the changes of energy is actually from the electrical energy to heat energy. So we must know the formula of electrical energy. So in this case, we are using E, electrical energy, equal to power P times time. So power P is the power of the immersion heater. Okay, normally in physics lab, we use 50 watt, 50 W, 50 watt immersion heater. Alright, so power times time, that is the formula for electrical energy. And then all the electrical energy is converted to heat energy by the immersion heater. Okay, so we can sum it like this. So Q equals to PT, so means that all the electrical energy change to heat energy. And then the formula for heat energy is MC, changes in temperature, delta theta. And then from there, we can combine this. Alright, so PT equals to MC theta. Alright, so this will be the data that we need to collect, okay, in order for us to determine the, to calculate the specific heat capacity. Alright, so detail for this experiment, okay, will be explained in another video. So please stay tuned, alright? Come, let us try some example. So 0.5 kg metal block is heated by 50 watt electrical heater for 90 seconds. the temperature of the block rises from 20 degrees Celsius to 45 degrees Celsius. Calculate the specific heat capacity of the metal. Okay, so we better write down the symbol. So 0.5 kilograms, so this is the mass. So the symbol is M. And then heated by a 50 watt, so this is actually power. Okay, and then for 90 seconds, so this is the time T. So the temperature changes. So this is actually delta theta. Now you can use the formula, right? Since the changes of energy is from electrical energy to heat energy, so you can use formula PT equal Q, which is MC theta. Alright, so P now is 50, and then the time taken is 90 seconds. So equal to the mass of the metal block is 0.5, and then you need to determine the specific heat capacity, and then the changes in temperature is from 20 to 45. So the changes of temperature is 45 minus 20. Okay, like that. So actually this sentence will be giving you 1 mark. Okay, then when you show the changes in temperature here, so 45 minus 20, so this is the second mark. Okay, and then your final answer you calculate using your calculator, okay, which is equal to this with the correct unit. So this is mark number 3. Okay, so you can write like this, but I prefer student to write the formula and then substitute. So at least you can get mark for the substitute value and then your final answer. Okay. We look at example number 2. So 20 gram of boiling water at 100 degrees Celsius is poured into a glass that contain 200 gram of water at 28 degrees Celsius. So now means that we mix the boiling water and the cold water. Okay, so you need to calculate the final temperature of the mixture of water. Okay, so logically, the final temperature of the mixture water will be less than 100 degrees Celsius, but will be more than 28 degrees Celsius. So here, it actually involves of heat energy release and absorb. So which one will release heat energy? Yes, the one that has higher temperature. So the 20 gram of boiling water, okay, will release heat. And then that heat release will be absorbed by the smaller temperature water. Okay, so it will be like this. Okay, so 20 gram water, 100 degrees Celsius will release heat, and then that heat release will be absorbed by the 200 gram of water. Okay, so we can write like this: Q1 equal to Q2. Okay, like that. Okay, and then Q1, okay, the 20 gram water will have changes of temperature. Okay, so you can use this formula. So M1C changes in temperature, and then equal to the 200 gram water also have changes in temperature. Okay, so since C here, if you don't substitute also no problem because it refer to water. The specific heat capacity will be the same. You can cancel C. And then M1 is the mass of that hot water, 20 gram. Okay, so change to kilogram, so 0.02. And then that M2 will be the 200 gram water. So change to kilogram, get 0.2. Okay, and then the changes of temperature. So the hot water, okay, will release heat and the final temperature will be less than 100. So let's say the final temperature is Y. Yeah? So the changes in temperature for that 20 gram water will be 100 minus Y. So that's why we can write like this. And then the 200 gram water changes in temperature will be, see, the final temperature of course will be more than 28. So Y minus 28 like that. Okay. Then you just expand using your mathematics. Then you calculate, you will get Y. The final temperature of the mixture will be 34.55 degrees Celsius. So in terms of mark, so this sentence will give you 1 mark. And then what I mean is the substitute value will be 1 mark. And then how you write the changes in temperature, this one can be given another mark, mark number 2. Of course, the final answer with correct unit will be mark number 3. Okay, so hopefully you can understand this. Application of specific heat capacity. First application is when we design cooking pot. So cooking pot have 2 parts. One is the handle and then the other one is the body. So if let's say you want to cook food faster, so the body and also the base of the cooking pot should be made by using what? Yeah, smaller specific heat capacity material. And then at the same time, when you cook, of course, you need to hold your cooking pot. So the handle should be made by using higher specific heat capacity material. Why is that so? Alright, so when the handle is made by using higher specific heat capacity material, means that the handle will heat up slowly. So means that the handle can absorb more heat, but the changes of temperature for the handle will be lower. Okay, so means it's safe for you to hold the handle. But for the body of the cooking pot and also the base of the cooking pot, okay, we normally use either aluminium body and also base copper. Okay, so copper actually has smaller specific heat capacity compared to aluminium, but then copper is denser, right? So that is why copper will be best to be used for the base of the cooking pot. Okay, so copper has smaller specific heat capacity, hence it will heat up faster. So the food inside will be cooked faster. Okay, and the density of copper is bigger compared to aluminium. Okay, so this will make the cooking pot stable. Aluminium has low specific heat capacity and it has low density. Alright, so it means that the cooking pot will not be that heavy. Okay, so it make the cooking pot lighter. And aluminium also does not react with the food in the pot. Okay, so safe for us to eat the food. Alright. Can you guess what happened to the car? Do you see the steam coming out from the bonnet of the car? So actually this car break down due to overheated. At the bonnet of the car, we have this part, what we call as radiator. So this is the cap of a radiator. And then this is, okay, the cap just now. So this is the cap. And then this thing is what we call the radiator. So the radiator is used to help to cool down the engine of the car. So this picture shows radiator also, so that clear for you to see. Zoom in, can see that radiator consists of fin, right? And then this fin is actually provide more surface so that more heat can be released to surrounding. Burning of fuel in car engine produce large amount of heat. So this heat must be released to avoid overheating of the engine. So normally we use water as the cooling agent because water has high specific heat capacity, that is 4200 joule per kg per degree Celsius. So the pump, here we have pump. So the pump will pump water into the car engine. Then the water will flow through the engine block, okay, to absorb heat produced. Alright, so the hot water flows to the radiator. So the hot water just now flows to the radiator. And then cold air is sucked in, okay, sucked in by the fan so that heat in the hot water can be released quickly through the cooling fin. Okay, so the cooling fin just now. So this is the cooling fin. So means that heat can be released more through the bigger surface area of the cooling fin. This picture shows a space capsule. astronaut will go back to Earth by using the space capsule. So on their journey back to Earth, the space capsule move at high speed. As it enter the atmosphere, so it will encounter a lot of friction, okay, between the body of the space capsule and also the air. So there will be a lot of heat produced. Okay, so with that, so what type of material should you choose to make the body of the space capsule? Should you choose smaller specific heat capacity, or should you choose higher specific heat capacity? Yes, correct. You should choose the higher specific heat capacity material to make the body of the space capsule. Higher specific heat capacity material will heat up slower. Okay, and another important characteristic will be we need to choose a higher melting point also, so that the space capsule will not melt easily. Modern building normally use a lot of electrical energy for the aircon to cool down the building. Okay, so nowadays they focus on the efficiency of energy. So this diamond building is actually the Energy Commission building, Suruhan Jaya Tenaga, that is located in Putrajaya. Okay, so in this diamond building, they are using styrofoam for the concrete roof. Okay, so that is to reduce the absorption of heat. Styrofoam is a material that has high specific heat capacity, which means it will be heat up slower. So means that styrofoam need to absorb more heat to increase the temperature by 1 degree Celsius. This is the use of higher specific heat capacity material. Natural phenomena, sea breeze and land breeze, also can be explained by using specific heat capacity. The land has smaller specific heat capacity compared to the seawater. During daytime, the land and the seawater will absorb heat. Since the land has smaller specific heat capacity, it will get hot faster. So the temperature of the land increase faster compared to the sea. So the land will be warmer. The air above the land, okay, will heat up and rise. So the cooler air from the sea will move towards the land. So we call that as sea breeze. So the process continue. And during night time, there is no sun anymore, right? So the land and the sea water will release heat. So when the land and the sea release heat, so as you know, land has smaller specific heat capacity, so means that it can release heat faster. As a result, the land will be cooler compared to the sea water. So the sea water is warmer, right? So the air above the sea water will be hotter, warmer. So the air rise up, and the cool air from the land, okay, will move to the sea. So this will create the land breeze. Okay, so I just prepared this picture for you for the sea breeze, and then this is for the land breeze. You can also use this table to compare between sea breeze and land breeze. Okay, so number one that you must remember, sea breeze occur during daytime, land breeze nighttime. And then the keyword that you better remember will be daytime, the land and sea water absorb heat. But nighttime, the land and sea water will release heat. Okay, so the land will always have smaller specific heat capacity compared to the sea. Sea has bigger specific heat capacity. And then during daytime, since the land absorb heat, so the land will heat up faster compared to the sea. Okay, so it means that land will be hotter. So the air above the land is warmer, so the warm air will move up. Okay, and then as for the sea, it has bigger specific heat capacity, so it will be heat up slower during daytime. Okay, then sea will be cooler, air above sea is cooler, so the cool air move from sea to the land, so we call that as sea breeze. And for the land breeze, it occurs during night time. Okay, remember the keyword just now. So during night time, there is no sun, so it means that the land and the seawater will release heat. The land has smaller specific heat capacity, hence the land will release heat faster compared to the seawater. So it means that the land will be cooler. So the air above the land is cooler. Okay, and as for the sea, it has bigger specific heat capacity, hence it will release heat slower. So during night time, the sea is warmer. So air above the sea is warmer. So the warm air move up. Okay, so the cool air above the land will move to the sea. So we call that as land breeze. Okay, so try to remember the keyword. You can also memorize the picture so that you can explain. And when you explain about this, you can also draw this, label your diagram carefully. You can get mark from here. Okay, we will do exercise on this. All right, so stay tuned for next video. Let us do some exercise. I would love to advise you to try first before you proceed with the video. Okay, so because in order to be good at physics, so you need to do more exercise. Okay, so we look at question number 1. Alright, so calculate the total heat that is absorbed by the copper block of mass 500 gram, which has been heated from 31 degrees Celsius to 80 degrees Celsius. So the specific heat capacity of copper is given. Okay, I already have the answer here. You try first, then you proceed with the video. Every time you want to answer physics question, so make it a habit to underline the keyword. Okay, so read the question carefully. It's like this. Calculate the total heat that is absorbed by the copper block with a mass of 500 gram. Be careful with the unit. So this is the mass, so it means that we are using symbol M. Okay, 500 gram, which has been heated from 31 degrees Celsius to 80 degrees Celsius. So the 31 degrees Celsius to 80 degrees Celsius is actually the change in temperature. Okay, so what formula should we use to determine the total heat absorbed? Yes, we use Q equal to MC theta. And after you, it's better for you to write the formula first like this, okay, Q equal to MC theta. Then you substitute the value correctly. Okay, be careful with the unit. Okay, now you see, the mass must be in kilogram. So if you see here is gram, so change it to kilogram. So 0.5 kilogram mass, which is 500 gram, 500 gram here. All right, times the specific heat capacity for copper, and then times the change in temperature. So 80 minus 31, that is the change in temperature. So you use your calculator, calculate correctly. Yeah, you will get this answer. Okay, so don't forget to write the unit. So the unit is in joule. Okay, so in terms of marking, so the substitute value here, this is the first mark, 1 mark, and then the final answer with correct unit is the second mark. So in this case, 2 marks given, right? Question number 2. So an electric heater with a power rating, power 2 kilowatt. So this is P. Be careful with this prefix. Kilo means 10 to the power of 3. Is used to heat up 4 kilogram of water. So this is the mass for 1 minute. So this one is T. Be careful with the unit also because we need to change this to second. So calculate the increase in temperature. Increase in temperature means that delta theta, okay, of the water. So the specific heat capacity of water is given, and then we assume that there is no heat loss to the surrounding. Okay, so to solve this problem, which formula should you use? So you can see now we have power, we have electric heater, heat up. So means that the changes of energy will be from electrical energy to heat energy. So we need to use this formula. So PT will be from the electrical energy and then change to heat energy. So from here you can substitute correctly. P is the power. Okay, so you see now here we have 2 kilowatt. So kilo must be changed, alright? So it must be in watt. Okay, 2 times 10 to the power of 3. So this is kilo. And then times time. So the time here must be in second. So we have 1 minute. So change to second. So times 60. It's better to show this step. Okay. And then M is the mass. So the mass of the water is 4 kilogram. And then the specific heat capacity of the water is given. Alright, now you can use your calculator, calculate the change in temperature. Okay, you will get that answer. Alright, so don't forget to write the final unit. Okay, so this question can give you up to 3 marks. So the first mark is given when you show this sentence. So means that when you substitute P, T, M, C. Okay, so this will be 1 mark. Okay. So when you show this, you change from 2 kilowatt to watt and from minute to second. So here can be given another mark. Okay. And then of course your final answer will be mark number 3. Okay, the last question. 300 gram of water at a temperature of 40 degrees Celsius is mixed with 900 gram of water at a temperature of 80 degrees Celsius. If there is no heat loss to surrounding, what is the final temperature when the thermal equilibrium is achieved by the mixture of water? So it means that we mix this 300 and 900 gram of water and we calculate what is the final temperature of the mixture. So you must have this idea in your mind. So we have 300 gram of water and the temperature is 40 degree Celsius. And we have 900 gram of water at a temperature of 80 degrees Celsius. So these water are mixed and you need to determine the final temperature. By looking at this 40 and 80 degrees Celsius, the final temperature will be in between these two temperatures. So let's say final temperature is theta. So the changes in temperature experienced by this 300 gram of water will be theta minus 40. Why theta minus 40? Because theta is more than 40, right? And then for the 900 gram water, the changes in temperature will be, which one? Theta minus 80 or 80 minus theta? It should be bigger temperature minus initial temperature. So the bigger temperature is 80. So the changes of temperature for 900 gram of water will be 80 minus theta. Okay. So, and then another thing that you must remember will be when we mix two liquid like this, so it will involve energy, heat energy release and absorb. Which one will release heat energy? Yes, the one that has higher temperature. So means that the 900 gram water will release heat. So I can say Q out. Okay. And then 300 gram water will absorb heat. So here will be Q in. Right? And then Q release, the heat released by 900 gram of water will be the same, equal as the Q absorbed by the 300 gram of water. So with this, you can write a proper formula, okay, using this. Alright, so Q in by 300 gram is the same as Q out by the 900 gram of water. So from here, you can write this, okay, using Q equal to MC theta. So this is the mass of the water. They give you in gram, can change to kilogram, and then specific heat capacity of the water, and then the changes in temperature. Okay, so theta is the final temperature minus 40, because this one is the heat absorbed. The 300 gram of water. And then for the Q out, okay, so use the same formula. In this case, C is the same, specific heat capacity of water. Okay, so you can cancel it. And you use your calculator, calculate theta. Okay, use your mathematics here. You need to expand it first. Expand the equation first. Okay, and calculate theta. So from here, you will see, you will get theta equal to 70. Don't forget the unit degree Celsius. So this question normally give you around 3 marks. So mark number 1 will be for the substitute value for the first sentence like this. This is mark number 1. Mark number 2 is for the changes in temperature. So see here, it's either theta minus 40 and 80 minus theta. So this is mark number 2. And then of course your final answer, mark number 3. Okay. I want to highlight again, if the object or the material has small value of specific heat capacity, it can be heat up and cool down at a faster rate. Okay, and then the material will be sensitive to the temperature changes. Okay, so for example, you see metal like iron, steel, copper, and aluminium used as pot and pans because they can be quickly heat up. Okay, when there is only small heat absorbed. And then the material also will be sensitive to the temperature changes. Example, mercury that is used in the thermometer has very low specific heat capacity. So it enables heat to be absorbed and released faster. Okay, although small quantity of heat are absorbed or released. Okay, and then for the high value of the specific heat capacity material, so it will be heat up and cool down at slower rate. Okay, so it means that it will require more heat to raise the temperature by specific amount. All right, and then it will be a very poor conductor of heat. So normally the handle of the pot, we use higher specific heat capacity material. And then higher specific heat capacity material also can absorb a great amount of heat without high changes in temperature. Okay, just that is why, that is the reason why water, okay, is used in the radiator. Okay, it can be used as a cooling agent because it can absorb more amount of heat, but the changes of temperature will be very low. Alright, so we already come to the end of the lesson. If you follow until here, so please comment below PT equal to MC theta. I don't know whether your handphone or you have this symbol or not. Okay, otherwise just write MC theta. Alright. Okay, so till we meet again. Alright, so hopefully you can understand this lesson and hopefully you can perform well not only in physics exam but also in your life. Alright, so see you. Assalamualaikum warahmatullahi wabarakatuh.